In this brief presentation, we're going to discuss how z-scores can be used to put into perspective what a raw score on an instrument actually tells us. Of standard scores. Z-scores, T-scores are two of the most common. What you need to know about a standard score, regardless of how it's used, is that they provide a method of expressing any raw score based on a normal distribution. In other words, it allows you to take a raw score and compare that score to a large group or population. So in our discussions about the normal curve and the normal distribution, the standard score is what enables counselors to make decisions about what a score actually means. Score is going to do is it's going to express that raw score in standard deviation units. Remember, we can take any raw score and place that in perspective on a normal curve if we know the mean and the standard deviation of the population. So here, we're just going to express that raw score in terms of a standard deviation unit, which will usually fall anywhere from -3 standard deviations to +3 standard deviations. What you have here is the formula for computing the z-score. Notice that you have three elements: the raw score, which is shown by x, the mean of the population, which is shown by x bar, and the standard deviation of the population, which is shown by a sigma. So we'll use these elements to compute the z-score. In this example, let's say that we administer some type of assessment instrument to a student, and the student scores a score of 76. On that test, the population mean is 82 with a standard deviation of 4. We just plug and chug. 76, our raw score, minus the mean, 82, is -6, divided by the standard deviation 4, which gives us a z-score of -1.5. In other words, a score of 76 is -1.5 standard deviations below the mean.